Our College of Engineering here does research across a really broad spectrum. There are faculty that work on what you might consider traditional engineering research areas: fluids, materials, heat transfer, electronics. But these days, there probably is no such thing really as traditional engineering. Everything is transdisciplinary in many ways. We see so much of engineering applied to medicine. We see engineering applied to energy. We see engineering applied to transportation. These are all problems that challenge us as a society, and engineering really is pushing the envelope and figuring out how do we create new models, new materials, new products that are going to help solve the problems that we have as a society.
UMass Lowell tends to focus on manufacturing processes, and most of the equipment that you will see here has a lot of focus on scalability, and it's equipment that companies would use in the actual manufacturing environment. Nanomanufacturing is taking the nanoscience and technology developments and scaling them into commercial products. The HEROES project is a collaboration between the Natick Soldiers Center at Natick here in Massachusetts and our Nanomanufacturing Center as one of the participants. And what we're trying to do is make new products for the soldier that are lighter in weight and have better performance. The unique opportunity of what we have here is that we have a lot of macro-scale plastics processing equipment in which we can integrate the nano manufacturing processes that we have here. So the opportunity is to get different scales, nanoscale, microscale, macro scale, that are important for advanced manufacturing tools that I think the whole country will need.
MC10 is a venture-backed startup located in Cambridge, Massachusetts. We're fundamentally reshaping electronics. We're taking rigid, boxy electronics that you'd find in your laptop, your tablet, your cell phone, and we're making them into conformal sheets or patches that can be worn on the body, or even in some cases go in the body. The largest challenge with trying to make electronics conformal and taking them out of a rigid box is it starts to pull on even more disciplines than the traditional supply chain for electronics. It pulls on more materials, more processes, and even more types of background from your employees. So it becomes more of a challenge to kind of manage that fusion of technologies. UMass Lowell helps MC10 by accelerating our product development. By having access to the facilities, we can get very quick cycles of learning, iterate on our products, help develop our core technology, but also push out this generation of product with a focus on the next generation of product as well. MC10's been thrilled with their experience to date with UMass Lowell and looks forward to expanding upon the relationship. We've benefited greatly in our product development by using state-of-the-art facilities and equipment and working with world-class personnel.
The research I do is in the area of cancer nanotechnology. We use very tiny nanoparticles. As the name suggests, these are much smaller than the width of your hair, about 1,000 times smaller than the width of your hair. And we use them to deliver drugs to the right site within the body. The problem with cancer is the drug is very toxic and it goes to every part of the body. So if you can sort of use these particles to deliver drugs only to the tumor tissue or the cancer site, you would be more effectively killing only the cancer while avoiding these very bad side effects that you typically associate with chemotherapeutic drugs. I think in terms of medicine, there's this one train of thought that most doctors or oncologists take, and by involving engineers, they get a totally different point of view. It's only when you have people with an engineering background, people with a basic science background, and doctors working together will we ever find a cure for a disease as complex as cancer.
The Difference Maker program started at the University of Massachusetts Lowell, and its aim is to find students who have an idea to solve a problem, a need that's in society. I started in the Difference Maker program and pitched my robotic arm idea. The robotic arm is an assistive technology device that enables users who currently rely on a feeding staff to feed themselves. It uses a simple 2-button interface for those who have limited motor control, who can engage the buttons to manipulate the arm. The school's been very helpful, giving me opportunities through the Difference Maker, getting some funding. Also, I've been working with one of the professors in the electrical engineering department. He's enabled me to create a thesis based around the whole concept of the robotic arm. And that's helping me as well, working one-on-one with someone who has a ton of experience in this field, allowing me to get the design to reach greater potentials to help a broader need.
The College of Engineering is one of the colleges here that works a lot with industry. And a lot of it is related to solving some of the challenges that the industry has. It also is creating some of the new technology that our industry can pick up on in order to make the next generation of products. We all know that it's a global competition these days, and for our companies to succeed, they have to stay ahead of the technology curve. And it's the faculty research here coupled with understanding industry challenges that is going to make that happen.